lets us focus again.
Yeah, it's fine. I mean, it just kind of, yeah, go on.
So we're going to have a chat about impulse, which leads on naturally from our thinking about conservation of momentum, because impulse is just another way of saying change in momentum. Impulse means change in momentum. And we're going to think about what change in momentum means. And so thinking about, going back to thinking about vectors for change, because momentum is a vector, we know that the change in momentum is going to be the final momentum minus the initial momentum, because change is always final minus initial.
Is that chemistry?
Not in chemistry?
No, this is like chemistry.
Like chemistry?
It's almost like it's science.
It's almost like it's math.
And that's not something that you're going to spot on your formula sheet, but that's something that we kind of expect you to know, that to find the change, you take the final one and you minus off the initial one. And if it's a vector quantity, like velocity or like momentum, you're going to have to do that subtraction as vectors. Yeah, we've learned how to do that. Box that one up. But then the definition of impulse that's useful for us is one that connects the change in momentum to the force that acts and how long that force acts for. So the one that you will find on your formula sheet is that change in momentum is the force times by the duration that it acts for.
Baba boy. Una piensa.
Oh, cold B.
Scratch it. What are these things measured in? We've got the duration that the force acts for. Seconds. Good. And we've got the force that acts. Newtons. And we've got the impulse, the change in momentum.
kgs per second.
Kg meters per second, or
Newton's
seconds.
Newton seconds.
Newton seconds. We just created a new
And
thing.
so this is kind of where conservation of momentum comes from, right? Because what we know from Newton's third law is that Newton's third law. What's that? For every
action
force,
there's
reaction.
equal and opposite.
Reaction.
Good. And so we know that whenever there's a force acting for a time, that means there must be an equal force acting in the opposite direction for an equal time. And so any two bodies that are interacting with each other are both going to have the same force acting for the same amount of time, and so they're both going to get the same change in momentum, but in opposite directions. So that's why there is such a thing as conservation of momentum. But this is useful for way more than that. This is useful for things like bow. What's your favourite pastime, Bo?
Cricket, I don't know.
Cricket. You're going to talk to us about the clothes that you wear when you play cricket.
What do you mean?
There's some special clothing that you wear. Talk to us about how do you dress for cricket.
White? I don't know.
Pants.
Is that important?
White clothes, pants. What else?
Oh, I mean you're batting.
Bullseye.
Are you batting?
Protection or
Protection? You got protection? What do you wear for protection?
helmet?
Helmet?
Cup, gloves.
A what?
Gloves?
Cushion?
No.
No pads, yeah.
Leg
Pads.
guards.
And what are those things, what are they for?
Protection.
So when you're bad,
Protection
you get
against what? What are you protected against?
The ball, the momentum of the ball.
Hang on, that ball still hits you. You're still going to have the same collision. It's still got the same momentum. How can wearing protection?
Is it absorbing?
What is it? How does it help you?
Maybe it doesn't.
Or it
Spreads the force over the area.
Spreads the force over the
time.
over the time.
What?
So
Wait,
wearing
how?
protection, it can't change the momentum, it can't change the collision, but it can change the time it takes for that collision to happen. So by making the collision take longer, like if it goes from taking 0.01 of a second to 0.1 of a second, it's like the collision is 10 times longer in duration. That means the force is only going to be 1/10 the size. And it's the force that
This is
breaks
crazy, guys.
you. Like when you get hit by something, the harder it hits you, the more likely you are to break, the more damage it does. And so by making that collision take longer, we can reduce the forces that act and thereby reduce the injury that happens. Same with crumple zones on cars. Like, why do we design modern cars to brake when they crash? It makes the collision take longer. Makes the collision take longer, makes the forces less. You're more likely to walk away from a car that crumples up than you are from some...
As long as it doesn't
Like-
crumple up your seat.
Doesn't it?
Isn't
Isn't it the other way
Yeah,
around?
yeah. But it's like, if it crumpled up
Isn't it-
fully, then it's not going to be.
Have you seen the videos of like antique cars crashing into modern ones, and the
Yeah.
dummy and the antique one just gets minced
The
against
car looks fine, but the dummy gets minced, right?
Yeah.
Yeah. So, this is the idea of all these different bits of protective equipment.
Boldness. Makes him nuts.
So you should edit in some clips of cars crashing.
Yeah, I got one to show you in a sec with like old car versus brand new car. What
Baba
happens?
boy. Baba boy.
Bubble boy.
Oh, so much why
Physics video breaks the fourth.
You'd have to write it down at all.
Wait,
On YouTube. Why would you?
Oh, it's actually true.
Oh, too late
This is like the new teaching. Like you don't have to take anything down because what you learn is what we discuss in class, right? It's like the arguments you have in class are what you actually learn. Like copying stuff down is nice, but it's on YouTube anyway.